Hello everyone, my name is Tawhid. I'm a researcher in Structural System Laboratory under the supervision of Professor Duki Kim. In this video, we'll learn how to model a cabinet using ANSYS Workbench. So at first video, today it will be our first tutorial video, a brief tutorial where we will learn basic modeling approach for a steel cabinet using ANSYS Workbench. So this is the dimensions and measurements, and the total cabinet will be like this. So in this video, we will actually follow these four procedures. First, we'll model the base plate, which is this portion at the base, and then we'll model the base, maintaining accurate measurements, and then we'll model the cabinet frames, internal frames, which will support the total structure. The frames will consist of primary frames and the secondary frames. We'll discuss this later. And then at last we'll model the outer plates. So at first, if we open the ANSYS Workbench, this window will pop up, and in this window, first we have to select the geometry. We'll drag the geometry in this portion, and then if we click on the geometry, there will be option. If we right click on the geometry, there will be option whether we want to model our structure in design modular or space claim. So in this video we will select the space claim. This is actually more convenient and faster. So space claim will take 5 to 10 seconds to pop up, and if it does, a window like this will come out. Then in here, so this is actually our drawing surface. We'll draw here in each portion by portion, and then we'll model our total cabinet following our precise measurements and dimensions. So as I said, first we'll start on the modeling using space claim, and we'll start with the base plate. So as we can see here, the base plate is actually 800 by 11,000. It's actually 11,000 by 11,000. Sorry, 1100 by 1100. Yeah. Okay, let me take this to another display so it will be easier for me to watch. Okay, and now we are in the window. We'll select the rectangle. The shortcut of the rectangle is R. I can either click here or I can just press R. The rectangle will active. Then let's start with the center. I will click on the define rectangle from center, and I will click here. So this is the center, and rectangle will actually start drawing from the centers. So as I said, our base plate dimensions are actually 1100 by 1100, and the scale is in millimeter. You can change it as per your requirement, but also in our study the scale is in millimeter. So if we model like this, the rectangle by base plate will pop up. If I show you, we have actually 1 2 3 4 5 6 7 1 2 3 4 5 10 and 18 bolt holes in our base plate. 16 actually, sorry. 16 bolt holes, and we also have to model the bolt holes. And as I said, we will model this in solid model in this video. Later we'll continue in other videos as a shell or line element. So let's select. So base plate dimension is done. Let me select the bolt holes. So bolt holes are actually 30 mm. There are 30 mm dia. And so we'll have 1 2 3 4 5 1 2 3 4 5 6 7 8 6 7 8, total 16 bolt holes. So to do this, we'll have to select the Cartesian dimension first, and let's select the corner, and the bolt will start from the 50 through the x-axis, and also 50 mm from the z-axis. So write minus 50 tab plus 50. Yeah, so the dimension will actually starts from there. And if we put the diameter of this, it is 30 mm. So 30 mm is like this. So we'll have to draw all 16 of the bolt holes, but there's a smarter way to do this. Let me show you. First we select a construction line. Yeah, this is a construction line, and just draw a simple line here, and then draw another simple line here, which will actually make you model this faster. Then press the right click, then press the right click, set as a mirror line, also press the right click, also set as a mirror line. So if we do this, everything we drew in this axis will actually be mirrored on the other axis. Same way, if we do this something over here, it will also be mirrored on the opposite axis of this model circle. And use Cartesian dimension first, then put a measurement over here, minus 50 tab 50. So it came over here. See, whatever we draw here, it's actually drawing on the four corners, so it's actually more convenient. And now we put the diameter of 30 mm. It is over here. Done. All four corners are modeled precisely, are drawn precisely. Okay, then just draw a line from the center to the center of this line for our own convenience, and then take another circle. So the shortcut of circle is C, so I'll press C, and I'll draw another one in the middle. See, in our previous approach we put the diameter at 30 mm, but in here it already snapped at 30, exactly 30. So if we draw here, you can see the other axes are already drawn, right? Same way, if we take a line, shortcut line is L, and draw a line from here, we can actually delete this one, it's fine. And there's another thing we need to make sure. Whenever we draw lines, even if we draw multiple lines at same place, lines actually don't overlap in space claim, which is a good thing. So that's why even if I mirror this multiple times, it will not overlap. I will actually clear this one later. Then press C again, and another circle bolt holes. See, they're actually precisely done. So it is done, and then I'm drawing another bolt holes over here, another bolt holes over here. So as I was saying, all bolt holes are drawn, and the thing we actually mentioned before, in space claim, even if we draw multiple lines at the same place, multiple shapes at the same place, lines usually don't overlap. If I show you precisely that this, if we delete it once, it will be actually deleted properly, totally, so there's no overlap. See, it's actually only one. Even if you draw it multiple times, it will stay at one. So our bolt holes and base plates are drawn properly, accurately, and precisely. Now we can delete the lines first, and delete the lines first, the thing we used as the reference. Now we can delete the mirrors. So base plate is modeled, and if we check this, it's a surface right now, and as you can see here, the base plate thickness is 19.8 mm. So we'll actually pull this thing. The pull shortcut is P, but we have this icon over here. You can also do this one, or we can just press P. So pull is activated, and then if we pull this, we can pull this as much as we want. You can either drag this to your own measurement, and you can just leave it, and it will be like this. Or let's play Ctrl Z, And if we do this and 19.8, we press 19.8, the base plate is modeled accurately on this frame. Okay, so our base plate with bolt holes is modeled. Let's mark this as done. Okay, good.